today we are talking about inequalities in two triangles. And again, inequality, things that are not equal. Okay? Now, and we just got done talking about inequalities in one triangle, now we're talking about inequalities in two separate triangles, comparing things. And the hinge theorem, which states this: if two sides of one triangle are congruent to two sides of a second triangle, alright, and the included angle of the first triangle is larger than the included angle of the second triangle, alright, then the third side of this first one is longer than the third side of the second one. Okay, think about that. These two sides are congruent, and then these angles are changing here. Alright, so you have your arms here. The two sides are congruent, not necessarily to each other, but in the two separate triangles. Now the included angle here at my chest, alright, if it's larger, what happens to that opposite side? If it's smaller, that angle, what happens to that opposite side? Okay, if the angle's larger, that third side is obviously larger. If the included angle is smaller, that opposite side of that third side is smaller as well. Okay, so comparing those angles, you then can compare those third sides. So in this case, length WX is greater than length ST. Okay, so that's the hinge theorem. Alright, it's like a door hinge, you know. The wider you open the door, the wider the gap between the door and the door frame. Okay. The converse is also true. So if you have two sides, of one triangle congruent to two sides of a second triangle, all right, and the third side in the first triangle is longer than the third side of the second triangle, then we can talk about angles C and F. We can have some kind of relationship between those two angles. And again, if this side is larger than that side, then the measure of angle C is going to be greater than the measure of angle F. Okay? Alright. In this example, given that segment ST is congruent to segment PR, these two segments are congruent. How does angle PST, that's this angle here, compare to angle SPR? And that's this angle. How do those two angles compare? Okay, and we're also given that length PT is 24 inches and length RS is 23 inches. Alright, so how do those angles compare to each other? Alright, well, we know these sides are congruent, we're given that. We also know that the two triangles are sharing that side. Okay, so we have, if I draw them in corresponding position, okay, we have SPT, that's 24 inches. That side and this side are congruent. And this is the angle we're looking at. Alright, and I have my second triangle. This is the angle we're looking at, which is angle P. This is 23 inches. Okay, segment PR is congruent to segment ST, so P, this has to be R. Alright, then this one's congruent, and that is S. Okay, so what can we say about these two angles here? Angle PST and angle SPR. So we have two sides of one triangle that are congruent to two sides of a second triangle. The third sides are 24 inches and 23 inches respectively. What can we say about these two angles? Angle PST is here, angle SPR is there. Well, angle SPT should be, this is larger than this, so this angle should be larger than that angle, greater than. Here are two examples again. If length PR equals length PS, these two, and the measure of angle QPR, which is angle QPR here, is greater than angle QPS, which is longer, segment SQ or segment RQ? Okay, so, you know, angle QPR, that's this angle, is larger than this one. So, you know, this one's 50 degrees, this one's 40 degrees, right? What can we say about those segments? And again, the triangles have these sides are congruent, and they share those two sides. So we have two congruent sides in the two triangles. Alright, now these angles, I'm just putting an arbitrary number in there. Alright, a random number. Those satisfy this relationship. Okay, angle QPR is greater than angle QPS. Alright, what can we say about segment SQ and length RQ? Okay. This angle is larger than this angle, so this side is larger than this side. Length SQ is less than length RQ, or length RQ is greater than length SQ, whichever way you want to read it. Converse, if, okay, again, if these two lengths are still equal, length PR and PS, those are still equal, and then now length RQ is less than length SQ. RQ is less than SQ, so that's 8, and let's say this is 12. Right? That satisfies this. Our length RQ is less than length SQ. Which is larger, angle RPQ or angle SPQ? So we have these sides congruent, and again, the triangles share that side. So those are the sides are congruent. So we have two sides of one triangle congruent to two sides of a second triangle. The third sides have this relationship. Alright, length RQ is less than length SQ. What do we know about these two angles? Angle RPQ is this angle, and angle SPQ is this one here. Alright, and because this side is larger, this angle SPQ should also be larger, greater than. Angle SPQ is greater than angle RPQ. Or you can read it by angle RPQ is less than angle SPQ. So, inequalities in two triangles. There is a relationship between the angle measures and the sides. We don't know the exact lengths or angle measures, but if we know this kind of a relationship, we can determine this kind of a relationship. And vice versa, if we know this kind of relationship, we can determine that kind of relationship. Okay? If we know this angle pair or this relationship with the angles, we know then this relationship with the sides. We don't know the actual values. I just picked random or arbitrary values just to show this relationship that we have here. Okay? Please come to class if you have any questions concerning inequalities in two triangles. Thank you.